Okay, good morning, everyone. Can you hear my voice, all of you?
Yes, sir.
Okay, thank you. Okay, everyone, please give your attendance at first. Okay, those who are joining in my class, please give your attendance at first. Okay, okay. Again, I am asking you, all of you, can you hear my voice? Am I audible?
Yes, sir.
Okay, can you see my board clearly?
Yes, sir.
Okay, thank you. Okay, everyone, please mute yourself. Okay, so in our previous class, we already discussed about the singularities and the pole and also the residues of a function. How to find out the residues of a function. Um, I think one theorem is discussed here, which is uh, residues of a multiple point. Okay. So how to find out the residues of a multiple point? I will show you today by using a theorem. So residues at a multiple point. So at first, please tell me what is the residue of a simple point or simple pole or single pole. What is the formula for finding the residue of a single by using or of a simple pole of a function, complex function? Do you remember? Okay, I just again this is there it is a minus 1 limit z tends to a z minus a into f. So this is the residue for a simple pole of a complex function. Okay. So now today I am going to show you how to find out the residue for higher pole of order. Okay, that means কিভাবে পোল অফ অর্ডারটা হায়ার হলে দ্যাট মিনস হচ্ছে তোমার ডাবল ট্রিপল বা হায়ার হলে আমরা কিভাবে সেটাকে সেটার জন্য আমাদের রেসিডিউস ফর্মুলাটা কি হবে সেটা নিয়ে আজকে ডিসকাস করবো আর ওকে নাও here is the theorem. Okay. So let f be analytic inside and on a simple step as sorry, this full order of two steps. Everyone please mute yourself. Ragib, please mute yourself. So, this is the residue formula for multiple points. Okay. If the simple that means if the pole of order n will occur, then you can say here a minus 1 equals to limit here a subscript minus 1 equals to limit z tends to a 1 by factorial n minus 1 d to the power n minus 1 divided by dz to the power n minus 1 into z minus a to the power n dot lz. Okay, so this is for simple pole and this is for multiple polar order. That means the double polars, triple and higher. Okay, now I just prove, I'll show you the proof of this theorem. So let me start this from here. So at first you have to use a Lorentz series for proving this theorem. Okay. So what is our Lorentz series? Do you remember the formula of Lorentz series of a complex function? I told that in my previous classes. Okay.
Sir, f of z is equal to
Yes, f of z equals to
summation of n is equal to minus infinity to infinity.
n equals to here what n minus n or
To
minus
the power
1
n into z
minus
a to the power n.
a to the power n. Here this is
Minus
0 to
infinity to infinity, sir.
here 0 to infinity. Okay, and then again another one is n close to 1 to infinity, and here also minus 1 into z minus a to the power n. Okay, so this is our Lorentz extension. Okay, so at first you have to use this equation for proving this theorem, where residues for multiple uh, points of a function, complex function. Now, I just write it down. A fz has a pole a of order n. Then by Lorentz series, you can say this. Okay. Now, you can write these things in this way, which is if you put n equals to 0, you can get a naught, and also this is 1. Again, if you put n equals to 1, you can get a 1, z minus a, and also a to z minus a whole square. Okay, and after that, for infinity term, you can write these things. And also, plus, you can also write that. Sorry, this is minus. Okay. Now, also you can write these things in this way, which is if you put a equals to, n equals to 1, you can say this. Also, okay. And for n terms, you can also say that thing like this, which is divided by a to the power. Okay. So now here you clearly see that this is our fz, which is our Lorentz extension. Okay. Now you have to find out limit z tends to a, also 1 by n minus 1 factorial into d to the power n minus 1 divided by dz to the power n minus 1, and also you can say this is what? This is our z minus a to the power n into lz. So here given lz equals to that. Okay. Now you have to multiply z minus a to the power n from both sides. Okay. Just multiply z minus a to the power n in this equation. Okay. So if I multiply this thing, you can get z into equation 1 multiply 1. You can get z minus a to the power n. If z equals to, you can also say here a not z minus a to the power n plus 10 a1. This will be z minus a to the power n plus 1, and also at last you can say here a minus, sorry, a plus minus 1 into z minus a to the power a minus 1. Okay. And after that, you can also say that it is, can you see my board clearly, everyone?
Yes.
স্যার অনেকটা ঝাপসা স্যার।
Okay, okay, I get it. My thing is so light. So that's right. Okay. And at last, you can get here, it will be a minus a. Okay. So সবার শেষে আমার থাকছে হচ্ছে plus a minus a. Okay. Now here, just look at here. Here you can get z minus a to the power n dot lz. Now what we have to do for proving this theorem? The formula which I given at first, which is limit z tends to a 1 by m minus 1 factorial. Okay. And also d to the power m minus 1 divided by dz to the power m minus 1. And then this thing. Okay. So that means what we have to do in our next step. Can anyone?
Differentiate করতে হবে স্যার।
Yeah. So
Sir, we will put the value.
again, this I don't understand.
Differentiate করতে হবে স্যার।
Yeah. So you have to differentiate this thing m minus 1 times. Okay. And after that, taking the limit of the function, which is z tends to a. Okay. So you can find out your required result by using this test. Okay. So if I say so, it will be our equation. This is equation 2. Okay. So if I differentiate equation 2 n minus 1 times, we can get with respect to what? Obviously, z. Okay. We have, then you can say this is e to the power n minus 1, is z to the power n minus 1, and also z minus a into fz. Okay. And this is turns into a naught into n factor. And also here will be z minus a. Again, we can write this in this way. n minus 1 divided by 2 factorial, also z minus a whole square. And after that, there's at first so if I differentiate this thing with respect to z n minus 1 times, then you can get the required result will be a naught into m factorial dot z minus a plus a1 m minus 1 factorial by uh, 2 factorial, and also z minus a whole square. And at last also you can get which is a subscript minus 1 into m minus 1 factorial. Just এটা তোমরা জানো এই জিনিসটা যে ডিফারেন্সিয়েট করলে n টাইমস পর্যন্ত তাহলে সেই ফ্যাক্টরিয়ালটা আমরা চলে আসে। যদি n টাইমস হয় তাহলে n টাইমস and m minus 1 times হবে, obviously this will be m minus 1 factorial. Okay, now just take the limit. Z tends to a, we get. So tell me, if I take the limit z tends to a, then what we can get in this equation?
m minus 1 factorial a inverse.
Yes. So just if I take z tends to a, that means here this turns into z tends to a. That means here to 2, and these terms will remove from here, and at last we can get here a minus 1 into m minus 1 factorial. Okay. So okay, yes, I just write this thing in here. Limit z tends to a to the power m minus 1 divided by n minus 1. Also here z minus a into fz. If I take limits, so this term and this term will be gone, so we can get minus 1. So from here you can easily say that n minus 1 equals to limit z tends to a 1 by n minus 1 factorial into dz d to the power n minus 1 divided by dz to the power n minus 1 into, sorry, এখানে একটা m ছিল, I just mistake in my first previous line. Here it will be n power n, here will be there. Okay, so here z minus a to the power n, because we multiply z minus a to the power n from both sides, okay, of equation 1. So here obviously z minus a to the power n will be occurred. So this is z. So this is the residue of a complex function if we have the double pole or above. Okay, so now I give you an example on this based on this theorem. So here, find residues of the function. If z equals to here z is minus 2z divided by a plus 1 square and also z plus 4. So z is plus 4. So we have to find out the residues of this function where the function is fz equals to z square minus 2z divided by z plus 1 whole square into z square plus 4. So what we have to do at first for find out the residues of this complex function? Anyone? Can anyone tell me about it? Here, our complex function is fz z square minus 2z divided by z plus 1 whole square and also z square plus 4. Okay, so at first you have to find out the pole of order m. Okay, so you have to find out the singularities there. I mean the singularities of this function. So what we should do for find out the pole of this function? Is it a simple or double pole of the order n or n? Just tell me.
ডিনোমিনেটরটা 0 ধরতে হবে।
Yes. Thank you. So you have to let the denominator equals to 0 or find out our criteria. Okay. So here for I just in this way the poles of Lz are obtained by solving this thing which is z plus 1 whole square and also z square plus 4 equals to 0. Okay. So you have to let the denominator of your given function equals to 0 for find out the pole of order n or n. Okay. So tell me here what is the value of z? Anyone? What is the value of z here? Here z plus 1 whole square. That means you can write values of z. One of them is minus 1 minus 1. Okay. So good. So here there is z plus 1 whole square. That means you can write these things in this way, which is z equals to minus 1 and also minus 1. Okay. And for this, what you can say, what is the value of z here? How can I find out the z value of z from z square plus 4? Anyone? এটা কেউ বলতে পারছো না কি হবে বলো একজন?
Sir, 2i plus minus 2i.
2i, sir.
Yes, so this is plus minus 2i. Okay, so here the value of z is different and here the similar values. Okay, so you can say here you can write this is z square minus 2i whole square equals to 0, and also you can say that here z equals to plus minus I. Okay, so here different values of z, which is plus 2i and also minus 2i, and for z plus 1 whole square, here the singular value z equals to minus 1 or minus 1. So how can I define this two poles from here? এটার নাম আমরা কি বলতে পারি? For z equals to minus 1, is it simple pole or double pole?
Double.
Yes, so this is a double pole of a function, because here two values we get, those are similar, and also here z equals to plus minus 2i, those are different values. Okay, so it will be our simple pole of this function. Okay, so for z equals to 2i and also z equals to minus 2i, you can use the residues formula, which is simple pole formula, and the formula is a minus 1 equal to limit z tends to a z minus a into fz. Okay, this is for simple pole. So here z equals to 2i and also z equals to minus 2i. You have to find out, you have to use this formula for these two values of z. Okay, দুইটা তোমাদের অ্যান্সার আসবে এটার জন্য, z equals to 2i এবং minus 2i এর জন্য, but অনেকটা similar. And also for double pole, what will be our formula for residue? Anyone? For double pole? বলতে পারবে? Yes. In our previous theorem, I already told you that you have to use the derivative term for find out the solution from your complex function. Okay, and the residues formula, that will be the residues formula. So for double pole, এখানে একের থেকে বেশি আছে, different, এটা একটা তো একটার জন্য আমরা এটা বের করছিলাম. So for double pole এর জন্য we have to use this formula, which is limit z tends to a 1 by m minus 1 factorial, also e to the power m minus 1 divided by dz to the power m minus 1 into z minus a to the power m into fz. So tell me, what is the value of m here?
Minus 1.
What is the value of a? Not a.
2, sir.
2. Yes. So here this is a double pole. That means the pole of order m, here m equals to 2. Okay. So that's why you have to use m equals to 2. So now I solve this problem. So this is so easy. Okay. So if I let say minus 1 is limit z tends to minus 1, also divided by 1, here 2 minus 1 factorial e to the power 2 minus 1, and also dz to the power 2 minus 1. Here you can get z minus a z plus 1 to the power m into 2, and also fz here, so already know that z square minus 2z divided by z plus 1 whole square and also z square plus 4. Okay. Since z equals to minus 1 is our double pole, so that's why you have to use this formula, derivative formula for residue, find the residues. So here limit z tends to minus 1, 1 by factorial 2 minus 1, and also 2 minus 1 factorial, and also d to the power 2 minus 1 divided by dz to the power 2 minus 1 into here z minus a is means z minus a to the power a means z plus 1 square, because m here it is 2 and also a here it is minus 1, and after that you have to put the value of the function fz, where fz is this. Okay, now just solve this thing. Here limit a tends to minus 1, that means 1, because factorial 1 means 1, all of you know that. So 1 by 1 factorial means obviously 1. Okay, so now here d by dz into z square 2z divided by z square plus 4. Okay, so now just solve this equation. So how can you solve this? Just you have to use UV method, U by V method. Okay, here U by V. So this one is U and this one is V. Okay, just apply the derivative formula U by V method. So what will be our result? Here you can write this thing, z square plus 4 into, if you differentiate it, you can get this. And again, here you can get z square minus 2z into 2z. And also this is z square plus 4 whole square. Okay. So now just simplify this equation. You can get the simplified thing. I just skip those some lines. After that, you can get limit z tends to minus 1 and also 2z square plus 8 z minus 8 divided by z square plus 4 whole square. Okay. Now, just what we have to do now? This. Tell me.
minus 1 বসাতে হবে স্যার যেটা
Yes, you have to put z equals to minus 1. So if you put z equals to minus 1, so you can get the result which is the finite. But if there is, যদি এখানে তোমাদের minus 1 হওয়ার পর 0 হয়ে যেত, তখন কি করতে হতো? 0 by 0 বা something. ঠিক খেয়াল আছে?
ডিনোমিনেটর দিয়ে গুণ করতে হতো
Yes, you have to use L hospital rules. Do you remember L hospital?
লাভ হবে ডিনোমিনেটর দিয়ে গুণ করতে হতো স্যার লাভ
Yeah. La hospital rules. Okay, so La hospital's rules used correct. You can also find out your finding value of this residues. Okay, so this is so easy. Another one is for simple residue. Simple solve. Okay, so you can get the result which is minus 14 by 25. This is residue for z equals to minus 1. Okay, and for z equals to minus 2y. Now for simple pole, we get simple pole for z equals to 2y and also minus 2y. So at first you have to take z equals to minus 2y, then you can write here residue minus equals to limit z tends to a, here z minus a into fz. So here a equals to 2y. So already know that here a equals to 2y and also z minus 2y and also fz, here it is z square minus 2z and z plus 1 whole square into z square plus 4. Okay, so this is our answer. Now again, just you simplify this equation where this is z minus 2y and also this is z square plus 4. So just convert it in a square minus b square formula, which is a plus b and also a minus b.
Plus
Then
2
you can get, yes,
plus 2i z minus 2i হয়েছে
yeah. So z minus 2y and also z plus 2y you can get, and just remove z minus 2y. Just এই দুইটা remove হয়ে যাচ্ছে কাটাকাটি দিয়ে, then at plus you can get here limit z tends to 2y, you can get z square minus 2z divided by z plus 1 whole square and also z plus 2y. Okay, and after that, just now, how can I solve this equation? How can I solve this?
z এর বদলে 2i বসাতে হবে
যেটা বলে যে 2y বসাবো, এছাড়া আরো ইজিয়েস্ট কোনো ওয়ে নেই? Okay, just
কমন নিতে হবে
you are right. Just you have to put z tends to 2y. That means z এর বদলে you have to put z equal to 2y. Then you can get 4i whole square minus 2 into 2y, and also you can get 2i plus 1 whole square and 2i plus 2y. And after that, just simplify this equation. Just তোমরা গুণ করো, বর্গ করো, then এখান থেকে দেখবে তোমরা তোমাদের রিকোয়ার্ড রেজাল্ট যেটা আসবে, which is 7 plus I divided by 25. Okay. So this is for simple for z equals to 2y, and also you can get z equals to minus 2y. The residue results will be just only দেখবে এখানে minus হয়ে যাবে. Okay. For minus 2y এর জন্য just সাইনটা চেঞ্জ হয়ে যাবে। দ্যাট মিনস হচ্ছে কনজুগেট কমপ্লেক্স নাম্বার যেটা থাকবে আই, সেটা নেগেটিভ সাইন হয়ে যাবে ফর নেগেটিভ ভ্যালুর জন্য। ওকে, all of you, can you got my point? Can you get my point, everyone?
yes sir.
Okay, is this clear? There is problem, কোনো প্রবলেম আছে তোমাদের? If there any problem, তোমাদের যদি প্রবলেম থাকে আমাকে আস্ক করতে পারো। Okay, maybe not. So that's all for today. তোমরা কি সবাই অ্যাটেন্ডেন্স দিয়েছো, everyone?
yes sir.